All right, so systems of inequalities. Yesterday we did regular inequalities, so we're still going to do all of these rules. We're still going to sometimes solve the inequality for y. Maybe that needs to happen. Hint, hint, on your homework, you'll have to do it twice for 2 problems. 2, you're going to graph it. You're going to use the solid line for greater than or equal to or less than or equal to. You're going to use the dotted line for greater than or less than. You're going to shade above the line if y is greater and shade below the line if y is less than. Not quite sure why there's an N on the word below. Same rules. However, today we're adding a system. It's not just an inequality, we've got a system. And here is the definition. A system of inequalities is a set of 2 or more. We will stick to 2, but yes, there can be 3, there can be 4. You can get all kinds of crazy. A set of 2 or more linear inequalities in this, oh my gosh, I'm having so much trouble today. In the same problem. So it's a set of 2 or more, we're sticking to 2, linear inequalities in the same problem. The solution, right? So yesterday we're going to graph these inequalities. We're going to put 2 lines, 2 inequalities on the same graph. The solution is all ordered pairs in the double shaded area. And I want you to glue right now your your graphs probably 4 spaces above the bottom, so we have some room up top. And they don't need to be trimmed this time since we just have 2. If you really need to, I understand that desire, but we're going to move on without you if it takes forever. Make sure you glue your graphs facing the right way. I know it sounds ridiculous, but students have been known to put their graphs so that the X and Y axis are wrong. I feel like we should talk to the people who watch the video. Like, you at home can feel free to draw your own graph. Yeah, like we're on a talk show. It's like I'm Bob Ross, that painter. I wish I had some happy little clouds to put on our picture. No. I mean, Bob Ross is amazing. All right, now here's the little bits of knowledge you need to know. Typically, a system is drawn with one of these brackets at the beginning, meaning that those two lines belong together. Otherwise, you'd be like, what? Why do these two lines line up perfectly? Right? So typically when you have an equation, or a system, they're grouped together with a bracket at the beginning. So if I had y is greater than 1/2 x minus 2, and I have 8x plus 4y is less than or equal to 12. And I'm going to change that problem really quick. I'm going to make it minus 4y just so we can have a little bit of practice. If I'm looking at that first inequality that we wrote down, y is greater than 1/2 x minus 2. Is the first inequality graphable? Yeah. First inequality, I can graph it right away. I don't have to do anything. How do I graph the first inequality? Where does it start, Corbin? Starts at -2. So down here, go to -2. And here's where I use colored pencils. I'm going to do the first one in red. You can do it in pencil and then do the other one in a different pencil. It doesn't matter. From -2, what do I do now? Up 1 and right 2. Rise over run. So up 1 to the right 2. Up 1 to the right 2. Up 1 to the right 2, and I'm going to do this as many times as I can, so I'm going to do the opposite, down and to the left, down and to the left, down and to the left. Is this a solid or a dotted line? Dotted, because it's less than or greater than. And do I shade above because y is greater, or do I shade below because y is less? Above. Because y is greater. It eats the y. Where does y get bigger? Up here. Now I'm going to switch to a different color, and I'm going to pick a color that contrasts, right? You don't want to necessarily do red and orange because they're so similar to each other. Now this second inequality, can I graph it? No, but can I make it graphable? Yes. What do I do first? Sam? Minus 8x from both sides. What's left over on the left side? -4y is less than or equal to -8x plus 12, right? I have one more step. What do I need to do? Divide by -4. Y, and remember from yesterday, we talked about this. This is a pre-algebra concept. When you divide by a negative number, the inequality flips over. What's -8 divided by -4? Positive 2x. And what's 12 divided by -4? -3. Now can you graph this? Yes. Where does this graph start? -3. I'm using blue. Doesn't matter. Where do I go from -3? Up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1, down 2, backward 1. Does this line stay dotted or does it get connected? Connected. And do I shade above or below? I shade above the line. The answer to this inequality is any ordered pair that is double shaded. I can't include this part in my answer because it's not double shaded. There's not red and blue. I can't include this part because there's not red and blue. But all of this in here works. Why does all of this work? Because I have red and blue together. It's double shaded. Sometimes it's a huge space that's double shaded. Other times it's really little. Sometimes there's nothing double shaded. So would that problem have an answer? No, it'd be a no solution. Can you tell me an ordered pair that works in here? Grace? Or sorry, not Grace. Genesis? -1 what? -4 what? -4, 4. Yep, that works. Could you pick something on the lines? It's just in that area. Anything. The answer is the graph, right? Because how many answers are there? There are infinite answers. So we're just picking random spots in here that work. Right? This part is interpreting the solution. What does this graph mean? It means that -4, 4 is an answer. It means that 0, 0 is an answer. It means that -4, -2 is an answer. It means -2.5, +2.5 is an answer. Any of those dots, ordered pairs that fit in that shaded area. So could you, going back to my question, could you pick something that's on the lines?
Only the blue line.
Only the blue line. Why only the blue line?
Because the blue line is solid, the red line is solid.
Because the blue line is solid. The blue line has an equal to, so it could be on the blue line. It cannot be on the red line because the red line is not equal to. All right, so let's do one more. This one's going to be easy. Y is greater than or equal to -4, and x is less than or equal to 3. Guess we didn't need all of this space down here. Ladies and gentlemen, can you tell me where y equals -4? Can you give me an ordered pair where the y value is -4? Lillian. 0, -4. Can someone else give me another ordered pair where the y value, because this isn't written with y equals mx plus b, this is just y equals. What's another ordered pair? Keegan? What? 1, -4. All right, let's plot those two. 0, -4. 1, -4. What do you see? Where do you think this line is going to go?
Nowhere.
It's going to go somewhere.
Well,
What's the slope of this line? 0. So where's my next dot going to go? Right here? And I keep going, right? The slope of that line, what touches the variable x? Nothing. The number 0. Is this solid or dotted? Solid. And is y bigger, meaning go above, or is y smaller, meaning go below? Is y greater or is y less? Y is greater, so we go above. All right, this next one, again, doesn't have a y and an x. It just has an x. So this problem, can you tell me an ordered pair where the x value is 3? Sam? 3, 4. Can you give me another ordered pair where the x value is 3? Corbin? 3, 5. All right, let's plot those. 3, 4, and 3, 5. Where do you think these dots are going to go? Up and down. That's okay. I got frozen. All right, is this going to be connected or dotted? What is it? Connected because it's got an equal to line. And ladies and gentlemen, here's my question because this is different. It says x. It doesn't say y. This problem says x. This problem says x. Or is x smaller? Is x getting bigger or is x getting smaller? X is smaller. Which way does x get smaller? This way. It only happens on problems that are just the x variable. The rest of them are the up and down, but this one has to shade to the left because the x gets smaller going to the left. So what's the answer? Everything that's double shaded. Anything in this rectangle. How many answers are there to this problem? Infinite answers. Could one of those answers be on the lines? Yes, because both of these are solid lines.